Today we'll talk about synapse. In synapse, we will talk about the structure of synapse and the transmission of synapse and the properties of synapse. So what is a synapse? Synapse is the junction between two neurons where the communication occurs, and it is classified based on anatomical and also physiological, that is functional. Coming to the anatomical classification, depending upon what structures are undergoing synapse: axonic, axodendritic, and axosomatic. So axon with axon, axon with the dendrite, and axon with the cell body. And coming to the functional classification, we have two synapses. One is electrical synapse, another one is chemical synapse. So if you see here, electrical synapse, the communication is by gap junction. And here in the chemical synapse, there occurs a neurotransmitter which communicates with the postsynaptic neuron. Coming to the electrical synapse, due to the presence of gap junctions, the information can pass bidirectional. So it is two-way conduction. Chemical synapse, a neurotransmitter is required. One example, acetylcholine will take, and either it may be excitatory or inhibitory, like GABA, excitatory like acetylcholine, and it is one-way conduction, that is from presynaptic neuron to postsynaptic neuron. And coming to the structure of the synapse, we have three structures in the synapse. One is presynaptic axon terminal, two the gap, that is synaptic cleft, and the postsynaptic neuron. So here is the synaptic junction, where this is the presynaptic terminal which contains the vesicles of neurotransmitter, and here are the site of exocytosis, and there is the space, we call that as synaptic cleft, and another neuron which is forming the postsynaptic membrane which contains the receptors for this neurotransmitter. So presynaptic axon terminal is nothing but the terminal button or the synaptic node, and it contains synaptic vesicles, and also it contains dense tufts which are the filamentous projections which helps in the exocytosis, and this synaptic knob contains active zones where they are rich with mitochondria and channels, and also that is the site of exocytosis. So active zone is the site of exocytosis. Coming to the synaptic cleft, is nothing but a space which is 20 to 15 nanometer space, and this space is filled with extracellular fluid, and also it contains acetylcholine esterase. If the neurotransmitter is acetylcholine, it contains the enzymes to destroy the neurotransmitter. And coming to the postsynaptic neuron, it contains receptors, and these receptors are bind to ligand-gated channels, and the opening of these channels will cause synaptic potential, either it may be excitatory or inhibitory. Coming to the synaptic transmission, first, if we take this as the presynaptic and this is the postsynaptic. So once the action potential reaches here, it causes the opening of calcium channels, and which causes the influx of calcium, that causes the binding of these vesicles to the membrane, and that leads to exocytosis. Now acetylcholine is released, and that binds to a ligand-gated channel which opens a sodium channel, let us think, it causes depolarization. So voltage-gated calcium channels open, calcium-mediated exocytosis occurs, and acetylcholine plus ligand binds, and that produces the opening of ligand-gated sodium channels, influx of sodium, depolarization, and we'll get excitatory postsynaptic potential. So excitatory postsynaptic potential is a local potential that is generated due to the influx of sodium. And coming to the properties of synapse, so one is law of forward conduction, synaptic delay, law of divergence and convergence, postsynaptic potentials, synaptic inhibitions, summation, occlusion, subliminal fringe, and synaptic plasticity. Now we'll talk about all these properties individually. One is forward conduction, also called as one-way conduction. So in a chemical synapse, the conduction is one way, that is from presynaptic terminal to postsynaptic terminal. Synaptic delay, usually there occurs a synaptic delay of 0.5 milliseconds. So whatever the information the presynaptic terminal gives, that reaches the postsynaptic terminal with a gap. Why that gap? That is due to one, the events at that synaptic terminal, that is calcium entry, neurotransmitter release, binding to ligand, opening of ligand gated channels, and development of excited postsynaptic potentials. All these occur within this short duration. That's why there is a delay, synaptic delay. Law of divergence and law of convergence. So divergence is one axon, one cell body is giving synapses to many, and convergence is many gives to one, and this is the physiological basis for summation and facilitation. What is summation and facilitation? We'll look in the next one. Postsynaptic potentials, if it is depolarization, we'll get EPSP, that is excitatory postsynaptic potential. We already mentioned the events there. And inhibitory, when it is causing hyperpolarization, you will get inhibitory postsynaptic potential, IPSP. And synaptic inhibition, based on where the inhibition is occurring, either in the presynaptic, it is called indirect, direct or postsynaptic inhibition, Renshaw cell inhibition or feedback inhibition, and feed forward inhibition. So what is this direct inhibition or inhibitory postsynaptic potential? So if the inhibition is occurring at the postsynaptic neuron, if the inhibition is occurring, we are calling that as direct inhibition. So usually an inhibitory neurotransmitter is released, it binds to the ligand, causes the opening of either potassium channels or chloride instead of sodium. So sodium is not opened. So chloride influx means adding negative charge inside, or K plus Flex, that is also adding negative charge inside, so which is causing hyperpolarization. So hyperpolarization is causing a inhibitory postsynaptic potential, that is direct. Coming to the indirect, where the presynaptic neuron itself is inhibited, so decreased release of neurotransmitter. So inhibited neuron is inhibiting the presynaptic neuron. So what are the inhibitions which inhibit the presynaptic neuron? Or Renshaw cell or feedback inhibition. Let us think that this is the axon which is stimulating an interneuron called as Renshaw cell. Once this Renshaw cell is activated, it itself is inhibiting its mother motor neuron or mother axon. So it is inhibiting itself. That is a Renshaw cell or feedback inhibition. And also this Renshaw cell is giving an inhibitory information to the other neuron, that is called as lateral inhibition. So this is a presynaptic inhibition. And also one more is feed forward inhibition. Let us think here. The clamping fibers are stimulating the Purkinje cells in the cerebellar cortex, and these Purkinje cells are stimulating a network of fibers called as parallel fibers, which are stimulating the basket cells. The basket cells in turn are inhibiting the Purkinje cells. So this is a feed forward inhibition. Stimulatory, then inhibitory. Coming to the summation. So when we give two subthreshold stimuli, they summate and they will generate the action potential. We call that as summation. So to add, and there are two kinds, temporal and spatial. Coming to spatial summation, here many presynaptic neurons are simultaneously stimulated, so that all these stimuli potential are summed up to generate an action potential. That is spatial summation. So same time but different places. I can simply say that space is separating the stimuli. Okay. So spatial summation. Coming to the temporal summation, same presynaptic neuron stimulated within a less duration. So time is separating them. So that is temporal summation. Occlusion. What is occlusion is, so if you see here, if I take this A neurons synaptic zone is having 1, 2, 3, 4, 5, 6, 7, 8, 9. So A is having 9 synaptic neurons and B is also having 9. So if we simultaneously stimulate 9 A and B, we should have 18 neurons to be stimulated, so that we should have a tension of 18 neurons. But as there is overlap between 6 neurons, we are getting simultaneously stimulated only 12 because of overlap of innervation. So instead of 18, we are getting only 12. So 6 are occluded because of overlap. This is called occlusion. And subliminal fringe, similar story, but here A is innervating only 3, B is innervating only 3. But when we stimulate the A plus B, we are getting 12 instead of 6. Why so? Some 6 neurons are located in the zone where when these 2 neurons are stimulated, they get summated and they will stimulate. So I can say that these are high threshold neurons, these are low threshold neurons in others. So simultaneous stimulus increases the tension, and the reason here is spatial summation. Synaptic plasticity. So synaptic conduction can be modulated, either can be increased or decreased with experience, and this synaptic plasticity property helps in the process of learning and memory. So what are those synaptic plasticity are? Post-tetanic potentiation. What is this post-tetanic potentiation is when you give brief tetanizing stimuli, so a smaller stimuli with high frequency in presynaptic neuron, these will cause generation of longer action potentials. That means it lasts for a longer duration, and the reason is due to increased calcium influx in presynaptic, and we call this as facilitation. So post-tetanic potentiation are due to brief presynaptic stimulation, and this brief presynaptic stimulation is causing prolonged action potentials because of increased calcium influx in presynaptic neuron. The question here, the thing is that it is presynaptic facilitation, and if you give instead of brief, prolonged, we get an effect called as long-term potentiation, and the response is due to increased calcium influx in postsynaptic neuron, not in the pre, in the post. If you give tetanizing stimuli for a longer duration, you will get the response more because of increased calcium conductance in the postsynaptic neuron. And long-term depression, not only facilitation, there is also depression. So if you give presynaptic neuron a stimuli which are at slower rate, that causes decreased calcium influx. And there is one more entity called as fatigue. If repeated stimulus is given, that decreases the postsynaptic response due to habituation and gradual inactivation of calcium channels, which causes decreased neurotransmitter release. Sensitization. So the synapse is sensitized. So even a minor stimuli can cause a response with increased calcium influx in presynaptic. And this is due to, this facilitation is due to the transmission is simultaneously accompanied by a pleasant or unpleasant sensation, and usually it is a short-lived. short duration. Thank you for your patient listening. So we talked about synapse, what is synapse, and classification of synapse, which is anatomical and physiological, functionally electrical and chemical, and we talked about events at synaptic junction, and talked about properties of synapse. So hope I am clear. Thank you for your patient listening.